Welcome to today's discussion. Today we are going through a question in Form 4 under differentiation and its applications. A question that was done in Kcse 2006, paper 1, question number 24. And the question reads, a particle moves along a straight line such that its displacement S in meters from a given point is given by, this is the displacement function in form of S being equal to t into the power of 3 minus 5t into the power of 2 plus 3t plus 4, where t is the time in seconds. Part A, find the displacement of the particle at t is 5 seconds, the velocity of the particle when t is 5 seconds, C, the values of t when the particle is momentarily at rest, and lastly, the acceleration of the particle when t is 2 seconds. We have already discussed about this particular section, and we said you could be given a question in the form of displacement. You can be given a question in form of velocity. You can also be given a question in form of acceleration. And anytime you are given displacement, you differentiate displacement to get velocity function, and then you differentiate the velocity function for you to get acceleration. And 2, you could be given a question in form of y, and then from y you could be required to differentiate the function y to get the dy over dx, which stands for the change in y over the change in x that refers to the gradient function of a curve. So let us look at the solution of this question. So the first part of the question, we have been given the displacement function in form of s, and s is equal to t cubed minus 5t squared plus 3t plus 4. And we are told to find the displacement of the particle at t is 5 seconds. Since we have the displacement function, we only need to substitute the value of t for us to get displacement. So at t is equal to 5 seconds, our displacement is going to be equal to t is 5, which is cubed, minus 5 into the value of t, which is 5, but it is squared, plus 3 into the value of t, which is 5, and lastly plus 4. And if you cube 5, you get 125. 5 squared is 25 times 5, which gives us negative 125. We have 5 times 3, which is 15, plus 4, and this one will give us 125 minus 125. This one will give you a 0, so we remain with 15 plus 4, giving us 19 meters. That is part A of the question, already worked out. We move to part B. Part B, we are supposed to find the velocity of the particle when t is equal to 5 seconds. Remember, the displacement function s is given by t cubed minus 5t squared plus 3t plus 4. So for us to get the velocity function, we need to differentiate displacement, that is v is equal to this ds over dt, That is the change in displacement over the change in time. And this one is going to give us, when we are differentiating, 3 comes down so that we get 3t. Then you go and less 1 from the power. We are going to remain with 2. Then we differentiate minus 5t squared. You bring 2 down so that you multiply with 5. We are going to have minus 10. Then you go and less 1 from the power. We are going to have t power 1, or simply t, plus you differentiate 3t, you get t. So we have the velocity function, and at t is equal to 5 seconds, velocity is going to be equal to 3 into the value of t, which is 5, squared, minus 10 into the value of t, which is 5, plus 3, and this one is going to give us 28 meters per second as the answer to part B of the question. We move down to part C. Part C, we are supposed to find the values of t when the particle is momentarily at rest, and always you should know that at rest the particle always has 0 velocity. Since we have the velocity function, we are going to take the velocity function, then we equate it to 0 before we work out the values of t. The velocity function we have is 3t squared minus 10t plus 3, and we know at rest the velocity is always equal to 0. So you realize what we have is a quadratic function, which is going to be solved using factorization method. We can use the other methods, but I prefer to use factorization. And under factorization, I need to look at the product, which is given by A times C, giving us 9 positive. Then the sum is equal to the coefficient of the linear term, which is negative 10. So we need two numbers whose product is positive 9 and their sum negative 10, and those numbers are negative 1 and negative 9. Once we have these numbers, we go down and write this function, that is 3t squared. Instead of now using the linear term, we split it using the numbers. That is, we are going to have minus 1t, or simply minus t, minus 9t plus 3 being equal to 0. Having done that, now we factorize them in pairs. We have between 3t squared and minus t, which one is common here? T is common, so we factor t outside. Once t is out, we remain with 3t minus 1. This bracket is the same, so we place it here, 3t minus 1. Then we look at the second pair, so this one is going to be equal to negative 3. So from here, we are going to have t minus 3. We pick 1 from the brackets, 3t minus 1, and this one is going to be equal to 0. Having done that, so we have t minus 3 being equal to 0. So if you take negative 3 to the other side, t is going to be equal to 3. Or t, that is 3t minus 1, will be equal to 0. If we take negative 1 to the other side, it will be positive. So 3t will be equal to positive 1. T is going to be equal to a third. Therefore we can say t will be equal to 3 seconds, another t will be equal to a third seconds. What it means is that the particle is momentarily at rest between t is equal to 3 seconds and t is equal to a third. We move to the last part, which is part D. And part D, we are supposed to find the acceleration of the particle when t is 2 seconds. Remember, we cannot get the acceleration without the acceleration function. From the velocity function, we are going to have the acceleration function. The velocity function v is equal to 3t squared minus 10t plus 3. Remember, to get acceleration, we differentiate velocity in respect to change in time. And this one is going to give us, you differentiate 3t squared, 2 comes down so that we have 6t. Then you less 1 from the power. We are going to have 6t raised to power 1, which is the same as 6t. Then you differentiate minus 10t, you are going to get minus 10. So we know when time is 2 seconds, our acceleration is going to be equal to 6 into t, which is 2, minus 10, and this one is going to give us 2 meters per second squared as our acceleration. And that is the answer to part D of this particular question. Thank you for watching and welcome to the channel. And in case you are new in this channel, kindly take that 1 second and click the subscribe button so that anytime we produce a video like this, you'll automatically be notified.